Here we have an AB calculus practice multiple choice question here, straight off the College Board website. Their free domain material to study by. You may want to pause the video first. Let's have it work this out. Let's take a look. Ice sculpture in the form of a sphere melts. It sounds like a related rate in such a way that it maintains a spherical shape. The volume is decreasing, at a constant rate of 2 pi cubic meters. Okay, so we're going to need that. 2 pi cubic meters right there per hour. At what rate is the surface area decreasing? Okay, when the radius is 5 meters. So remember, a related rate is kind of like you have a movie playing and you pause the movie at a certain place and you ask yourself, when you pause it, how quickly was the movie changing or a particular value changing? That's the way to think about a related rate. Obviously, there's multiple rates and they're associated, so let's take a look. All right, so first we write down the practical or the appropriate formula. In this case, it gives it to you. We're told the rate at which the volume is changing, so we need that volume formula. Okay, so that's the first thing we do. Is write down the appropriate formula. We'll then take the derivative with respect to time. Okay, now there is no t variable in here, so the derivative of v is just 1, but then you have to put this dv dt on it, this implicit differentiation. So then I've got 4/3 pi times 3 times r squared. Try again on the r squared, then again implicit differentiation dr dt. All right, so my volume, let's say my radius is 5, there's the yellow, and the v dt is right there. So generally after you take the implicit differentiation with respect to time, when you plug in all the variables, there's going to be one variable left, usually one rate left. So in this case, it's dr dt. So plugging things in, we've got 2 pi is 4/3 pi. Now I'll tell you what, let's just say, can we go ahead and say 4 right there? 4/3 times 3 is just 4. Okay, so 4 pi r squared, pen going, r squared, there we go, dr dt. Okay, and r is 5, isn't it? So let's go ahead and put 25 right there. dr dt. And I have trouble writing here. dt. Okay, so that 25 there comes from the 5 squared. Okay, so 4 times 25, that's 100. So you have 2 pi divided by 100 pi. That's going to be 1/50th. All right, so 1/50th, and then we're about the units is multiple choice. You don't have to worry so much about it. If you're just doing a calculus problem, you'd think about the units here. But that is your dr dt. Okay, again, that's 2 pi divided by 100 pi. Now it says, if you look at the question, at what rate is the surface area decreasing at the moment when the radius is 5 meters? So let's remember 1/50th. I'm going to back up, just get more room here. Let's go back here. Now the surface area, let's go ahead and change colors. The surface area formula is S equals 4 pi r squared. All right. So you take that with respect to time, ds dt, that's what we're looking for. That's going to be 8 pi r dr dt. But remember, we know dr dt is 1/50th. So that's going to be 8 times pi times 5. Again, that's in yellow there. Times 1/50th. Okay. And so if you take all that, 40, 8 times 5 is 40. 40 divided by 50 is 4/5. So the correct answer will be A, 4/5. All right, so remember that about our